Hi everybody. Is there anybody else waiting outside so we can close the doors? Welcome, thank you. Thank you for coming to our talk. Thank you for supporting local Croatian speakers, because there is a very nice talk about cloud native solutions in the other hall. We really appreciate it. Is there anybody here speaking English only? So should we continue in English or can we switch to... So we have English speaker. Okay, so we'll just continue in English. Okay. So thank you very much for coming. My name is Ivan. This is Tomislav. We are from Kroz. Today we would like to share some of our experiences in one-click OpenShift provisioning. Basically one-click OpenShift installation. So in a manner of Simon Sinek, we will start with why we did it, and then Tomislav will further continue with how and what we did actually. So why we did it, how it came to this one-click OpenShift provisioning. OpenShift has quite a history in Kroz. First installation was sometimes in the beginning of January 2016, so it's almost 3 years now. And it came around with one of our gurus, one of our enthusiasts who installed the first installation. And then a couple of other guys also used it for some of their applications. And everything started basically like this, as a child play. So we had some applications running on it. We usually tear it down, build it up again, configure it, reinstalling, and so on. And it was pretty nice for a while. And then a lot of other guys in company decided, this stuff is really good, we could use it for our applications as well. And then they put their application or our OpenShift. And then they somehow started to expect some kind of SLA from us. And they expected for this thing to actually work and not be down. And that basically led us to change our formation into something like this. So it wasn't a child play anymore. It became a really serious system inside our company, and somebody really needed to take care of it and patch it and make sure it works correctly. And we did it, but we had a lot of problems. I will mention three, the biggest ones now. The first one is, of course, increased load, because once they started putting all of their applications on our OpenShift, then things started to shake a bit, because we started with a cluster which had only one master and I think 2 worker nodes. And in the end, we ended up with 8 nodes. So during this process, we added 6 more nodes. And it's not a very complex thing to do. It's not either, complicated or hard, but it's very tedious, it's very boring, and it is something that you would very much like to do, like with a magic wand, just click it and there, bam, there is a new node. So it's not something that you want to spend your time on. The second thing that we also stumbled upon is the fact that once we put new node into production, mysteriously some applications failed to work correctly on that node. And then troubleshooting, we noticed that, wow, this node has completely different set of libraries on it installed, or there are all relevant libraries are there, but with different versions than on the other nodes. And so we decided, we failed at this point. We should have something called desired state. So we need a mechanism that will ensure that all nodes in our cluster are basically equal in terms of operating system, in terms of set of libraries installed, in terms of their versions and so on. So it also not something that is tremendously difficult to achieve, but it's error prone, it's very risky, because suddenly application fails and you don't know why that happens. And you want to have this also done somehow with a magic wand. And third thing that is specific for us is we are not a product company. We are a service company, which means that we have a lot of pilots and experiments and proof of concepts at our clients, and we are very often in a position that we need to install OpenShift from the ground up. So it's not like we install it once and use it for the next 10 years. We are basically installing it in one way or another, I don't know, on monthly basis. Very often experimenting with different hardware configurations, with different virtualizations. So we need a way to install this OpenShift, with as less stress as we can, and in a way that wouldn't take too much time from us. So all these things that I was talking about somehow lead to what can we do? We can automate somehow this installation to spend as less of our effort as possible. So we are going to achieve something that this is one of my favorite quotes in general from Warren Bennis. The factory of the future will have only two employees, a man and a dog. The man will be there to feed the dog will be there to keep the man from touching the equipment. So this is what we wanted to achieve. Let's have an automated system that installs everything, configures everything, and of course somebody needs to click something, but let's try to keep the number of clicks at one. So can we do all of this in only one click? What happened next is, this was a good idea, and there is a whole bunch of people at the company who are part of what we call DevOps community of practice, and we sat down and brainstormed a bit how to do it, and then we set a goal for ourselves. This was happening sometimes in November, I think, last year. And we said, okay, by the end of January, we will implement one-click OpenShift installation. And we also had a nice vision how to achieve it by using Ansible scripts and whatever it takes to get this one-click installation done. And we used Ansible, definitely we used some other tools, and Tomislav now will tell us a little bit about this how part of this initiative.
So, if anyone ever installed OpenShift, you know that OpenShift uses Ansible for its installation. So we started to look at Ansible. Ansible is a simple automation engine that can be used for configuration management, application deployments, and etc. It's agentless. That's perfect for us. And we created a bunch of scripts that uses Ansible to achieve the desired state of the nodes and the virtual machines that hosts OpenShift. Next tool that we used, and it was the major discovery, it's AWX. AWX is pretty much, you can think of it as a GUI for Ansible. It enables users to automate their Ansible scripts, workflows, deployments. Basically, it's just a GUI. You will see in the pictures how it looks like. It's a Red Hat product. It's open sourced. It's an upstream project of Red Hat Ansible Tower. Ansible Tower is pretty much enterprise AWX with selected releases and hardening in security. After that, we decided to take a look on the Red Hat's reference architecture. On Red Hat blog, there is a number of reference architecture that they provide for users as a know-how or as an idea what to use. We are installing our OpenShift on VMware, so we decided to modify this infrastructure. On the picture, we can see that there are 3 OpenShift masters, 2 infrastructure nodes, and 3 application nodes, and traffic is served through an external load balancer. We did something similar. This is our reference architecture. We have one load balancer. It's installed through OpenShift. We have 3 masters, 3 etcds, and 3 application nodes. In total, we used 25 CPUs, almost 100 gigabytes of RAM, and over 700 gigabytes of disk just for installation of the reference architecture for OpenShift. Our system admins weren't happy with that. Okay, and finally, how did we manage to do the one-click installation? So AWX works with projects and templates. On the left side, you can see a project. We have two projects. One project is pre-installed scripts. This is an Ansible playbook that achieves our desired state. Our desired state are, as Ivan mentioned, installation of tools that we need to monitor the VMs and other dependencies. Also, with the desired state, we create users that have access, SSH access to the machines. And the second one, Cross OpenShift 3.11, is de facto OpenShift Ansible on GitHub that is provided by Red Hat. On the right side, this is what's called an inventory. Inventory is a list of all the machines with the correct groups that will be used in AWX. After that we have created a project and an inventory, the next step is to create a workflow. On the pictures you can see that we have failed workflows because we did some testing before everything worked. We created 4 workflows in the end. First workflow is our desired state scripts, pre-install scripts. After that, OpenShift requires us to run its prerequisites. It's also hosted on the OpenShift GitHub repo. This installs some dependencies that are needed for OpenShift, and then we have the OpenShift deploy cluster template. This template does the actual installation of OpenShift. And after that, we have an install workflow template. This is what we call the one-click installation. So we select this workflow template and we click start job, and this is the visualization how this job looks like. So we have our prerequisites on success, then run OpenShift prerequisites, and on success install the OpenShift. After we click the install workflow start job button, we managed to install OpenShift in 35 minutes with just one click. So this was pretty big issue for us because I will talk a little later about problems that we have, because we started with the idea, and from start to finish we managed to do it everything in one month, let's say, 1 month. So we had problems with installing the OpenShift with AWX. The first one we had AWX installed, but no one knew how to use it. No one had the experience with AWX, so we needed to try it out, read the documentation and see how it works. After that, we find out that OpenShift very much likes specific versions of Ansible, and the AWX comes with the newest version. So we needed to figure out how to make AWX uses the old version of Ansible. So we found out that AWX uses Python virtual environments, and we managed to make that work. Also, we stumbled upon, let's say, standard OpenShift installation errors that was pretty much listed on the GitHub with the issues, and we needed to read through the GitHub issues to figure out the solutions, and it was repetitive process to get this installation done. I think that Oh, this is all for me. So Ivan will finish and then we can move to questions.
Thanks. Yeah, as Tomislav said, it didn't work. It wasn't going that smoothly. So we had a couple of problems. I think we had a good. It definitely wasn't the most important initiative in our company to build one-click OpenShift installation. But we did have buy-in from a lot of guys in the company, and we had something like this installed on a company TV, where we were frequently sharing our status and issues that we were stumbling upon. So as you can see here, sometimes in December we started working with AWX, and we had some problems, but we managed to fix them. And in the end, it's a cool initiative like this, interesting initiative like this, somehow manages to gather and round all the people around, and at some point everybody wants to join in and be part of the team that does something cool. And this is very much in line with what other guys were saying at the round table when they were talking about how to basically create a team that is gelled together and works together like one. We won't stop with only these functionalities with AWX. For example, once we have this whole infrastructure in place, we had this situation now where somebody needed to have all of his passwords reset or something on all the machines. And one way to do it is, of course, log into every single machine and change the password. The other option was for somebody, I believe it was actually Tomislav, who then wrote an Ansible script that does that. And then we put that script on AWX, and now we have it in our catalog. So the idea is, as Warren said, let's have a dog that will keep the man from touching the equipment. So let's have whatever we can automated and basically available on click for these tedious operations to get done by themselves, and not to have somebody waste his time on something like that. Is there something else that we actually wanted to say? Yeah, and this is a huge step also toward a concept called also infrastructure as a code. So with this infrastructure here and with this pilot ready, we are actually now able to reproduce every single environment on one click with all the infrastructure configuration stored either in SCM, in Git as scripts, or in AWX as an inventory of all the machines. So a huge plus for us is also this infrastructure as a code functionality. So we also want to leave some time for possible questions, and we would also like to leave you with what Jesse Frazell said. Hire the people who will automate themselves out of a job, and then just keep giving them jobs. So this is basically what we are doing with this guy here. So he likes to automate things, and we are just feeding him with things to do, and he tries to get himself out of the job. That's it. Thank you. I don't know if you have any questions or comments, possible improvements to this solution. That would be very appreciated. Yeah, or use something like, maybe we could use chatbot or voice recognition. Alexa.
We have a plan to do it with one enter. So you need to press enter and everything will be...
Yeah, we also had a fun fact. We also had an idea to have a live demo here, but we have a problem that the whole procedure lasts for 35 minutes, which is out of boundaries. We even went out of our way to order from Amazon that huge enter button that you just hit, and then everything happens, and it's sadly in our company on my desk, not used today, so maybe we'll ask for a bigger slot next time. Thank you again.